Hello, Engineer Hugo. My name is Juan David Pardo. In this case, I want to talk about my Activity 3 Task Software project. Okay, I want to talk about COCOMO II models analysis, um, characteristics, model adaptation. It's the evolution of the original COCOMO 81 redesigned to fit modern software lifecycle that as agile, rapid application development, and object-oriented programming, algorithmic nature. It uses mathematical forms based historical data to provide object estimation for force and duration. Flexibility is not a single model but a suite of three submodels that adapt to the project's maturity level. This is very important. Flexibility. Size oriented. Its primary input is the size of the software matured there in the logic source lines of code, slope, or function points. 2. Parameters. The model relies too many types of variables to adjust estimates. Its four multiplier cost drivers. These evaluate 18, 17 atributos for categories. In this case, first is product, complex reality, platform, memory and time constraints, personal, capability and experience, project, tools and multi-site development, scale, factory. These 5 factors determine the exponent of the equation and representation. Economics of scale. They include precedence, development flexibility, architecture rise, revolution, team cohesion, process maturity. 3. Operational concept. COCOMO II operates through the three distinct stages depending on the project phase. First, application composition model used for early prototyping and project build with UI tools. 2. Early design model applied after requirements are known but before the final architecture is set. 3. Post-architecture model, the most granular and detailed version used and the technical architecture is fully defined and established. 4. Mathematical models. The core equation for calculate efforts measured in person month is S4 equals A but EAF by key slug. First, a constant represented the baseline product, usually 215. EAF, effort adjustment factor, the product of all effort multiplier. Key slot, thousand of logical source line of codes. Scaling exponent, derived for the scaled factors. It reflects where the project has discommonness of scale, where complexities were fast in the size. 5. Algorithmic model of software cost. This model translates technical metrics into financial and temporal resources. It calculates the duration, time to development by relation the estimated for the project complexity. I enable management to assign monetary values to the project by multiply the estimated person month by the average labor cost of the technical staff. 6. Estimation model for projects. Subsystem based. It allows for estimate individual components or modules separately and they aggregate for the total project estimate. Domain specific. It includes specific factors to different application types, of client server of intranet system. Resource integration. According to Benny Gonzalez, 2016, the model incorporates resource factors to account for existing code, data validation routines, and generic class. 7. Consideration in the use model. Managers must be aware the several operational challenges with then use models. First, language variables. Slug count vary significantly between programming languages. For example, Java versus Python. Metric inconsistencies. There is no universal standard for lines of code, which I can lead to measure errors. Diverse application area. Estimate and real-time medical system is fundamentally different from estimation on simple business web app. This is very important. I depend of complexity to application to deploy, no? Quality standards. Team productivity is not always constant and depends heavily on the organization specification quality benchmark. I include a reference that is work. Y eso sería todo, ingeniero. Muchas gracias, un buen día.